on the Unit 3 review number 3, I went ahead and I graphed this. And for the purpose of not having to flip back and forth between Desmos and a piece of paper, I just gave myself a very simple graph of what this looks like, making sure I have to correctly identify the x-intercepts and the vertex, which occurs at 4, -2. So I'm going to go through it here, and I'm going to describe the end behavior all the way down to the domain and range. So end behavior, this is the function y. So we're describing which direction at the very ends are the y's going. So are they headed up or headed down? This says as I go to the far left, what's happening to the graph? And it is heading up. Up is with a positive infinity. As I go to the very far right, what's happening? It is also headed up. Parabolas are going to be going in the same direction, both up or both down. So end behavior is done. If you feel confident, you're going to put an X through it. A circle means I need to go back and review this. The vertex, yes, it can be found by simply looking here, or when you graph it, you can see what the vertex is as well. The vertex here is 4, -2 in parentheses. Remember, your equation of the axis of symmetry is not simply just a number, it's an equation. So it cuts through the x-axis, If you took a scissors, you'd go right through the x-axis at a value of 4. X equals 4. 4 alone, y equals 4 would not be correct answers. This particular function has a minimum value. It's one value that is the lowest on the graph. When they're asking for the minimum value, they want to know y equals what is the lowest. It is y equals -2. Not just -2, not x equals -2. Y equals -2. Increasing and decreasing intervals, always give yourself parentheses not to make the mistake. And then ask yourself, so you're coming in here, right? And from left to right, you're going down. So this is decreasing. And then you have a resting spot. I'm going to put a little X. And then you're increasing over here. Okay, so I'm going to start with the decreasing, which is number 38. So decreasing, it comes from the far left. How do I describe far left? Negative infinity. And it continues to decrease, so it gets to a resting point of 4. Increasing, after it leaves a resting point, always describe in terms of x values, after it leaves 4, it begins to increase as it moves to the far right. Intercepts. I can see the x-intercepts, so I'm going to come down here and say my x-intercepts can be found at 3, 0, and can be found at 5, 0, 3, 0, and 5, 0. And now, what about the y-intercept? Well, when you graph this, you will be able to see the y-intercept. If I flip back over here and I bring this down, I can simply click. I don't know if you can see that from your end, but it is at 0, 30, 0, 30. And I was able to achieve that without doing algebra, literally just graphing in Desmos and identifying where does the function cross the x-axis and the y-axis. Okay, where is it positive? So I'm going to see if I can use different colors here. Positive and negative. Negative is where is it below the x-axis? Positive means where is it above the x-axis. And when we describe these, we'll describe it in terms of x values. So in terms of x values, it's coming from the far left. This is positive. So it's coming from the far left, and it continues to be positive until it gets to this point. This is a neutral point because it's on the x-axis. The y value isn't positive, isn't negative, it's 0. It's neutral. So all the way to 3, it's positive. Negative infinity all the way to 3 is positive. Also, okay, once it leaves 5, it is positive as it moves to the right. So these two intervals describe where is the function positive. Where is the function negative? Right down here. Okay, once it leaves 3, it dips below the x-axis and it continues to be negative until it reaches 5. Why am I not putting brackets? Because at 3 and 5, it's neutral, and we want to know where is it positive and negative. Domain and range, I'm going to do D and R. There's no limit how far you go to the left and right. Feel free to think of yourself here as on the X bridge. You look up and you eventually would see this function. Again, you're here, and you see the function. Here, you look down below. So as you walk in the X bridge, you would always see, you have to use the binoculars, but you would always see some part of the function. The range, we start from down below, and as I move up, the first time I see the function
Please transition
is at
to
negative
second
2.
period.
And there's no limit how high it goes.